What else? Well, guess what? The Open Zeppelin wizard can help us with even more. Because what do we need next? Well, we need a DAO, right? We need a system. We need a contract to actually manage these votes, right? And guess what? The wizard has one called Governor. We can go through this and update settings. So we can update the name if we want. I'm going to leave it as my governor. A voting delay, which is anytime somebody proposes something, it says, okay, we're going to wait at least one block for the voting to start. Maybe you do something like 100 blocks. It depends on your chain. The voting period, for how long the voting will actually last. A proposal threshold, where it's the minimum number of votes an account must have to create a proposal. Most of the time, this is kept to 0. A quorum percentage of tokens that need to vote in order for something to pass. If there's 100 tokens in circulation, at least 4 tokens need to vote for it to pass. Make these settings updatable or not. This is to make the contracts fully compatible with Bravo, which is the compound implementation. The type of votes, you can have ERC20 votes. You can have ERC721 votes, which is an NFT or comp-like. A time lock controller. Anytime a vote passes, give users some amount of time to leave the DAO before it's implemented. And then upgradability. We probably want to avoid this as much as we can because, like I said before, security. And with that, I'm just going to leave all the settings to be default. We can literally copy this into our contract and not really have to do anything. So new file, my governor.sol, paste this in. And let's talk about what is going on in this contract. What are these different functions? So first off, let's update this to named imports. And we also need to import iVotes. This is going to come from governor votes. We're going to need to import this time lock controller, which is going to come from this governor time lock. And then we're going to have to import iGovernor, which is going to come from governor. And that's it. So just update these to named imports and we're good to go. So let's walk through what this is doing. So my governor is governor settings, governor counting, blah, 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 all this stuff. I'm going to give you the high level overview of what all of these does. This governor contract, if we command click into it or control click into it, is the core of the governance system. This governor contract, we control click into it. It brings us to governor votes, but let's go to the governor contract. This is kind of the main contract here. And how it works is it keeps this mapping basically of proposals, right? Each one of these proposals have a vote start, a vote ended, and then an executed or canceled. And that's really it. Every single time somebody submits a proposal, this mapping gets updated. And if we scroll down, we have this state function. This is the function that tells us if a proposal has passed based off of this mapping of proposals. If it's executed, if it's canceled, what's the deadline, has a quorum been reached, etc. This is what most user interfaces are going to read to see if a vote has passed or not. We keep scrolling down, we can see a proposal snapshot, which is basically getting the deadline, when the proposal is due. We can see some stuff like a proposal threshold, and then a whole bunch of unimplemented functions like quorum reached, vote success, get votes, etc. And this is because this governor function is this abstract contract meant to be extended on and implemented with. Governor votes is one of these extensions where it says, okay, ERC20 token voting. That's the way we're going to do votes. And this has a function like get votes, which reads the token voting weight from the token's built-in snapshot mechanism to get how often somebody can vote and that type of thing. Now in our governor, one of the main functions that we has is going to be propose. And these are going to be the variables it takes in. Targets is just going to be like a list of different contracts to make a transaction to. Values is going to be a list of values to send with each target. Call data, now that we know all about call data, is going to be the bytes data that we're going to send with each transaction. And then just a description, right? So for example, this might be like 0x0 blah, 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 some address here. And if it's just 1, it would just be like, one address here. If it's 2, it might be like this, etc. Values might be like, something like 0, meaning the transaction we send to this address, we're just going to pass 0 value. If there's 2 transactions with 2 addresses, like 0x, blah, 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 something or other, we could have 2 values, right? Call datas are going to be the call data for sending to here. And now that we know about function selectors, function signatures, and etc., we know that with this call data's section allows us to call any function and really send any data to this target that we want. So it makes it completely modular. And then some description, right? And this is really just for the internal state of the governor. You know, it might be something like proposal to send money to Dawn, right? And so if this was like 123, this is Dawn's address. Cool. We've just made a proposal to send money to Dawn, right? If this was, you know, like the link token contract, for example, we could have this be 0. We could find the function selector for transfer, and we could be like transfer function selector and encode, you know, and then encode all the data for transferring some link. We could then say proposal to send link to Chris or whatever we want to do here, right? So this is how we can propose any transaction for our DAO to do and send proposals. So really, really important function here. And if we go through it, we can see it hashes the proposal. It does a whole bunch of checks in here. It adds our proposals to that proposals mapping. It gets a deadline, picks a snapshot for votes and everything, emits a log, and importantly, it returns a proposal ID. The proposal ID is a hash of all the inputs so that this proposal ID will be unique. Then we have another important function called execute. And all of the inputs you can see are the same as the inputs up here, right? The only difference is it's saying a bytes 32 description hash. This is just going to be the encrypted description from up here. And it's this function that gets called, and it's this function, this execute function that gets called once a proposal has passed to actually send that proposal, right? So here it first reverse engineers and gets the proposal ID from all those inputs, which should be the same as what was proposed, and then says, okay, let's get the status of that proposal state based off of how the votes go. And if it's good to go, then go ahead and execute it, right? So we do some execute stuff here. The execute internal function actually sends it with some familiar stuff here, right? We're doing targets.call, values, call datas, etc. This is this low level functionality here. It's got some before execute stuff, some after execute stuff. We don't really need to worry too much about that. We can vote to cancel transactions. We can get votes. And then finally, another incredibly important function is going to be cast vote. And there's some derivatives of this, like cast vote with reason and params, cast vote by sig, a whole bunch of different ways to cast vote. But the main thing this cast vote thing does is it calls this internal cast vote function, which calls this internal cast vote function. And this is the actual function it calls. So it gets the proposal based off the proposal ID. It gets the weight of your vote based off of the snapshot of the tokens that you hold. Calls this internal count vote function, which basically just updates some internal state variables to add your votes to them, and then emits an event. That's it, right? And it updates your vote based off of whatever your weight is, which in the system that we're using, the more tokens you have, the more your vote counts. And those are the main functions here. So hopefully that made sense. I know I kind of went through that a little bit quickly, but that's kind of the basics of the governor. Now, governor is the main contract. Governor settings is just an extension to add stuff like voting delay, voting period, voting threshold, etc. Governor counting simple is also an extension, which is just an extension for a very simple counting mechanism. This extension allows our votes to be against, for, and abstain. And so we have this proposal vote. For each proposal, they get this struct, and this is where those votes get counted. We have against votes, for votes, abstain votes, and then a mapping of who has actually voted. Governor votes just implements this get votes contract. And governor votes quorum fraction. This is just an extension for token weight extraction. And then we have this important time lock controller function. Every single DAO should 100% always have this governor time lock control. Using this model means the proposal will be operated by the time lock controller and not the governor. Thus, the assets and permissions must be attached to the time lock controller. So we're actually going to deploy a contract called time lock that's going to own the governor. Anytime our governor contract votes on something and says, okay, this vote has passed, let's execute it, the time lock controller will say, okay, cool, but you have to wait X days or something. You can't execute without some delay. And it's really important to have this because if a DAO votes on something that a lot of people in the DAO hate, it gives them time to get out of the DAO before they get steamrolled, if you will. So really important to have this. And that's pretty much it. So we have some voting delay, voting period, quorum, state, propose. We have all these, which are just calling super, right? That's pretty much it. And that's all we really need for our governor contract, right? We have this constructor, which takes the token that we vote on as an input parameter and the time lock controller that's going to block us from executing proposals right away. The time lock controller contract is going to own our governor controller contract. And that's actually the last contract we need to create, a timelock.sol. So this is the only one we have to build ourselves, but we actually barely have to build it ourselves. SPX license identifier, pragma solidity, 0.8.18, caret, contract, time lock. And we barely have to implement this because OpenZeppelin already has one of these. So we just say our time lock is time lock controller. And then we can just import it, import at OpenZeppelin /contracts/governance/time lock controller.sol. Let's import it like this from, did I spell that right? Time lock controller. Okay, that's more right. Governance, contracts, OpenZeppelin, time lock controller. Okay, cool. That looks good. Now we'll just do a constructor and we'll pass some parameters in here. We'll say uint256 min delay, which we'll put a little comma here. This is going to be the min delay is how long you have to wait before executing. We're going to have to pass, and we can find all of these in the constructor of this. Min delay, proposers, executors, and admin, right? This is the constructor of the time lock controller. So we're going to need to have this be the constructor of ours as well. Min delay, we're going to need proposers is the list of addresses that can propose. So we need an initial list of proposers. We're going to update this so that it can be anybody. And then executors is the list of addresses that can execute. We're going to update this as well so that anytime a vote passes, anybody can execute it. So min delay, address array memory, proposers, address array memory, executors. Boom. And since this time lock controller parent class has a constructor, I'm going to toggle the word wrap. We got to put those in here, and it's just exactly the constructor parameters we created: min delay, proposers, executors, and then we also have to give it an admin, which we're just going to say is message.sender for now. And we need to give it an admin at first so that we can eventually move the time lock controller's admin so that only the DAO can do anything with the time lock controller. And you'll see us do that in a minute. But those are all the contracts that we need. That's it. We've written the contracts. We're done. Like I said, I'm going to do this kind of quickly. I do recommend that after this, you go back and you really try to understand what's going on here, because I know I'm kind of doing this quickly. But now we're going to write a test to show it actually work. And that's it. I'm not going to write a deploy script here. If you want to go back and you want to write a deploy script, that's great. But I'm just going to write a test to show you basically end to end exactly the process that happens in one of these DAOs.